I hope you're all doing fine. Okay, so today is our last day for our Araw fellows as we are gathered here for the final presentation. And we'd like to first start with an opening prayer. We'll call on our sister Patience to give us the opening prayer. Patience.
So let's pray. Almighty and ever-living God, we thank you very much for giving us this wonderful day. You who are our great provider and our strength, we thank you once again for bringing us here safely. Today we are here to witness the final presentation of our 2017 fellows. And as they are about to start, we ask that you will grant them all the necessary strength and aid so they are able to convey their message properly. This and many other blessings we ask. Please Jesus Christ our Lord and personal Savior. Amen.
Amen. Thank you very much, Patience. I'd like to invite Dr. Regina appear upon to give us our welcome address for this evening.
We want to thank God already. We have prayed and thank God. We thank God for this morning and a privilege to meet all of you lovely ladies of Araw who are going to make us proud also. Thank you. So on behalf of the board of directors of Araw, I want to welcome you all to this final presentation. And the idea is to ensure that you not only pick up these things, but you move on with them. I believe that when we had the introduction where a lot was said and so on, we know where Araw is coming from. So it's not just an event, an activity, and that is all. The idea is that you great women in science, that your names will be mentioned in annals of science. That is what we want, and that is what our prayer is, and that is what will happen. We believe that will happen. Okay. And so we are very confident that we are not working in vain. We are very confident. There are so many. The board of directors, if you know them, these are well-meaning people, and everybody's prayer is backing you. So although they are not here, I just want to assure you that the board is with you and with us. We sit and evaluate all these things that you have done. And so this morning, as I welcome you, I'm actually very excited, although I have not seen the slides as yet. Is Elikemp here? I couldn't make you attend more. Yes. So this morning we are very excited because we have already had a teaser with the presentations that we made in the middle part, where we had gone halfway, and so we are excited about this. And you should know that also we are going to encourage you. But be so relaxed. This is not a killing matter. And just share your experience with us. Let us enjoy this time together, okay? And those from Kumasi are here have been delayed, and that they will join us later. So I'll make my comments, other comments after we have finished. But feel relaxed, and we are very happy to meet you. Yes, thank you. Feel relaxed, we are very happy to have you. And again, on behalf of the board, I want to warmly welcome every one of us this morning. Thank you very much.
So much, I hope you're all getting excited about this. We already have had our progress report, progress presentation. So this should be a very calm one for us. Joining us is one of our
alumni from our 2014 year group at NACOCO, which is my group. So we'll be starting our presentation, and the first on our list, our first presenter is Hikmatu Al-Hassan.
I'm Hikmatu Al-Hassan from the University of Development Studies, and my project topic is acute flaccid paralysis surveillance and laboratory investigation polio eradication initiative. The poliovirus, which causes poliomyelitis, is from the family preconavirus, and it has icosahedral symmetry. This virus consists of an RNA genome enclosed in a protein shell known as the capsid. It is non-enveloped, hence referred to as a naked virus. There are three serotypes of this virus, namely polio type 1, polio type 2, and polio type 3. Polio type 2, which was declared eradicated in 2015 September, and with the last case recorded in India, that was in 1999. So we are left with polio type 1 and then polio type 3. The genomic structure of the poliovirus include the capsid protein made up of 60 copies each of the VP2, VP3, VP1, and then VP4, and then non-structural proteins. The disease poliomyelitis, which is caused by a human enterovirus, is transmitted through the orophycal route and replicates in the gastrointestinal tract. One out of 200 infections, the virus may enter into the bloodstream and then destroy the central nervous.
Hold on there.
In severe cases, it attacks motor neurons of the brain and sometimes even the spinal cord, affecting breathing, swallowing, and then speaking. 2 vaccines have been developed so far to immunize against this virus. The first one, which was developed by John Salk in 1955 from an inactive polio virus. And then the second one was developed by Albert Sabin in 1961 from an active but a weakened form of the polio virus. And that one is given orally. So the world has resorted to the use of the oral polio vaccine since it gives a long-lasting immunity than the injected poliovirus vaccine. However, the oral poliovirus causes a rare but adverse effect when given to children. It's recombined to a form that looks like the parent strain, thereby causing paralysis. And it cannot be distinguished from the parent strain, but through laboratory analysis, it can be distinguished from the parent strain. The clinical spectrum of the poliovirus infection. 0.5% out of 100 people who is infected with this virus is represented with the acute flaccid paralysis. 4 to 8% of those infected with this virus does not show normal viral symptoms without the paralysis, and 90 to 95% do not show any symptoms, therefore referred to as asymptomatic infection. The aim of my study was to provide timely and accurate information on the circulation of the wild poliovirus to enhance immunization activities and to achieve eradication. The workflow in the laboratory included sample receipt, retreatment, cell culture, inoculation, isolation, intratypic differentiation, and then sequencing. 2 samples were collected from 5 different countries, and they were Ghana, Mali, Benin, Togo, and Cote d'Ivoire. To increase the probability of isolating the virus, 2 samples were collected from each patient due to the intermittent shedding of the virus, and necessary data were recorded as to whether the 2 samples was adequate, and then they were given EPID numbers to be used throughout. After that, they were taken through treatment. Sample treatment was done to obtain a supernatant, which is believed to contain the virus, to be inoculated on cells. The following items were used: glass beads, PBS plus chloroform, and then chloroform-resistant tubes. The glass beads was 5 grams, approximately 5 grams of the glass bead was put into the centrifuge tube, and PBS plus, that is phosphate buffet saline with calcium and magnesium, and then antibiotics. The phosphate buffet saline was added to serve as a diluent, and the antibiotic to take care of bacterial growth if any present. And then the calcium and magnesium was to stabilize the virus during viral replication. The chloroform was added to take care of any other microbial growth. After all this mixture is prepared, the sample is taken to shake or agitated using the mechanical shaker for about 20 minutes, and then centrifuge at a speed of 3,600 revolutions per minute for another 20 minutes to obtain the supernatant. The supernatant was pipetted and aliquoted into tubes and stored at a temperature of -20 degrees to be later inoculated on cells. After treatment of samples, we needed cells to inoculate the virus on. The cell lines recommended for isolation of poliovirus include the L20B cells and the RD cells. The L20B cells, which is from a mound cell line, is genetically modified to express only the receptors of the poliovirus, and that of the RD cells, which is from the human rhabdomyosarcoma, is susceptible to enteroviruses as well as the poliovirus. 2 types of media were used in culturing: growth medium and the maintenance medium. They both had the same constraint, including L-glutamine, herpes buffer, FBS, that's fetal bovine serum, and then sodium bicarbonate. They had the same volume of constraint, except in the volume of FBS, which is the main growth factor, usually 10% in growth medium and 2% in maintenance medium. Growth medium is used to enhance rapid cell replication, and maintenance medium is intended to keep cells in a steady state of slow replication, and also to maintain the metabolism of cells during viral replication. When the cells were cultured, we needed to keep it in good shape, because when they are cultured, they produce toxins. And
your time is almost up, so I hope that you can. Yes.
The cells were passaged and then reused. After we had our cells, we proceeded to the isolation and identification of the virus. This involved the inoculation of the supernatant obtained from the treatment onto the cells, and the cells were then incubated at a temperature of 37 degrees Celsius. Cultures were examined daily using an inverted microscope for the appearance of cytopathic effects. This was done daily for 5 days, and all cell cultures that appeared to be positive on the L20B cells were repassaged onto RD cell lines to make sure that they were really enterovirus and poliovirus as well. Then after which, cells that were L20B positive were then taken through intratypic differentiation to know the serotype of the virus. The method used was the real-time PCR. In the PCR, we prepared a master mix with the kit that came with the real-time PCR kit, and 6 primers were used. The sample prepared with the master mix was kept into the thermocycler, and the viral RNA was converted to complementary DNA, then went through the process of denaturing, annealing, and primer extension, and the products were analyzed on the screen since it was real-time PCR. And this was how the results looked like. The results. Samples were collected from 5 different countries, and in total I had 290 cases. That is 558 580 samples, since 2 samples were taken from each patient. Out of the 290 cases, there were 30 isolates of non-polio enterovirus. That represents 10.3% of the total cases, and 260 negatives. That represents 89.3% of the total cases, and 1 suspected polio virus. The suspected polio virus was taken through the ITD, and the results shown that it was the 7 strain, and it was 7.3. That's the vaccine-derived polio virus. A range of enterovirus were found in the collected sample with an isolation rate of 30. That was 10.3%. Some of these enterovirus are associated with human disease. Example is the Coxsackie A virus, which is associated with the human acute hemorrhagic conjunctivitis, commonly known as Apollo, which Ghana had an outbreak in 1969. There were no positive cases with regards to the wild polio virus, and the presence of the Sabin-like polio virus was not an unexpected case, since immunization with the oral polio vaccine took place in those parts of the world. Even though this was this study was a pilot study with a limited number of samples, the study so far supports again the evidence of lack of circulation of the polio virus, as well as a wide range of circulation of non-polio enterovirus. Enterovirus may be a source of contamination in communities, especially in developing countries with limited resources in good sanitation and water. I recommend that we practice good personal hygiene and sanitation, and educating people on non-polio enterovirus as well as the polio enterovirus on the implications and also how to prevent them. Thank you.
You were very confident while speaking, but I didn't see a lot of interaction with your audience. You were focusing too much on the laptop. It was like you didn't have time to rehearse, and you were given too much details. For 10 minutes, you should skim through, highlighting on the very essential points. And it has to be very interactive. We should see some facial expression. This is something that you should have practiced like the whole time in the lab. So you just have to pick from your memory what you were doing in the lab. Don't try to go verbatim what you have on the screens. Thank you.
Thank you very much. Actually, please.
Thank you very much. That was a nice presentation. I saw, like, is it something like Apollo? I want to know, like, the Apollo, is it the one that affected the eye?
Acute hemorrhagic conjunctivitis.
So is it a type of polio? Like, is it part of polio?
No, it's caused by a non-polio enterovirus.
Thank you.
Hello everyone, my name is Karen Anaya Ajiman Atta, and today I'm come to share with you my findings for my project topic, that's the detection of Plasmodium species in asymptomatic individuals in Ho-Ho municipality. I hope you guys will enjoy this presentation because I found out something cool.
We are not all guys, you know. It should be a little bit more formal than...
Be formal. Okay, so this is a formal presentation.
So this is my outline. I'll start with my introduction, then move on into the issues, then finally my references. Okay, so malaria still remains a global health issue, and even in 2015, about 212 million cases of malaria was recorded worldwide, and this shows the severity of the situation. Even with the preventive and control measures that have actually been put in place to help solve the issue, it still remains a global health issue. The parasites of the genus Plasmodium are the causative agents of malaria. And out of the millions of species that are available, only 5 have been implicated in humans. And out of the 5, only 3 have been documented in Ghana. That's Plasmodium falciparum, Plasmodium malari, and Plasmodium ovale, and that's by the Ministry of Health in 2014. And even out of the 5, Plasmodium falciparum is kind of like the boss. It holds the championship of having the highest mortality rates in terms of malaria cases. And there's no effective vaccine that's available to help solve the problem. And even with the drugs that we have, they have been challenged by drug resistance. So it poses the question, what then is the way forward? So why am I doing this work? According to the Ho Municipality report in 2014, malaria was the leading cause of death. That's really sad, all the same. And no work has actually been done to determine the prevalence of Plasmodium species in Ho Municipality. However, work has been done in reference to the malaria cases in 5 urban as well as rural areas in Ho. And we know that the difference in the disease severity is in reference to the different Plasmodium species, knowing that Plasmodium falciparum causes more of like the severe malaria. So my aim, therefore, was to determine the prevalence of Plasmodium species in asymptomatic individuals in Ho Municipality, Ghana. But specifically, I wanted to know what species are actually present in these individuals, and then delve into which one is the most dominant. So that's my study design. My study site is Ho Municipality. And the samples, before the samples were collected, ethical clearance was sought out from the individuals in the required institutions. And my study is a cross-sectional study because I'm looking out for prevalence, and my sample size is 61. So this is what I employed in terms of experimental workflow. The samples were already collected before I got to the department, WACBEP, the West African Center for Cell Biology and Infectious Pathogens. And we then did DNA extraction using the Kilex method to extract parasite DNA if they were present within the samples. And then we moved on to do analysis of the DNA extracted using the nanodrop. And then we did nested PCR. Now, why I chose nested PCR was because I'm looking out for specificity at the same time sensitivity. So I'm doing 2 rounds of PCR. The first one is actually the primers target unique regions for the target regions that are common to all the Plasmodium species. Then the second round is for the various species, targeting unique regions in the 18S ribosomal RNA of the different species. So if then they are present in the samples, they will be identified. And then I did aggregate electrophoresis to view my bands. So this is what I expected. And the gel is in reference to the different species. The first S there is for the DNA ladder. And this is the 50 base pair ladder. And here, Plasmodium vivax S1, approximately 120. Plasmodium mallory having a band size of 144, and that follows for the rest of them. So these are the results I actually had. This is a representative show. I chose this gel specifically because the 2 samples that 2 species of Plasmodium were identified. That's Plasmodium mallory and Plasmodium falciparum. And you can see the band size just around there, 205 base pair. And then the same applies for Plasmodium mallory, is actually here. Thank you. Yes, so this gel was for 23 samples, and then the DNA ladder is just around here. So my results, after doing this, I realized that Plasmodium falciparum, or the samples that accounted for Plasmodium falciparum only were 44. Plasmodium mallory had no records for that, and the same for Valley. But I had 1 mixed infection. That was a cool thing for me. So 1 mixed infection for Plasmodium mallory and Plasmodium falciparum. However, 16 of my samples tested negative for all the Plasmodium species, so they didn't have the parasites present. So in terms of prevalence, Plasmodium falciparum took like the championship, 72%, and then there was 0% for Plasmodium mallory, and then 2% in terms of mixed infection, and 26 were negative. So I then concluded that Plasmodium species that are present in asymptomatic individuals in Ho Municipality were just 2. That's Plasmodium mallory and Plasmodium falciparum. Plasmodium falciparum then holds the championship, being the most dominant species, accounting for just 72% in terms of prevalence. And then finally, I had only 1 mixed infections recorded for Plasmodium falciparum and Plasmodium mallory, and there were no records for Valley as well as vivax. So I then thought, in terms of my recommendation, I think a larger, more representative sample size would do, because I had just had 61. I don't really think it's so much representative. And a longitudinal study will also help to check the patients for a period of time, a longer period of time. So that's the end of my presentation. I'd like to acknowledge God Almighty for seeing me through my 8 weeks at work there, a very wonderful experience. I would also like to thank the Araw team. You guys are like big time.
You like guys?
And I also like to thank my supervisor and mentor, Prof. Nawandari, a very great source of encouragement. Really helped me a lot with my progress and the like. So I'm really, really thankful.
It would be helpful if you could just mention your first name so that we can, you know.
Okay, my name is Araw, and my question is, from your results, you realized that there was no infection from PO Valley and P virus. And I would like to know if it's because of the location the samples were collected, or is there a reason? Because it could be that if the samples had been collected somewhere else, there could have been O Valley or virus. And I want to know if there is a specific place where you can find these samples, or what makes them dominant at some places and not at some places?
Okay, the reason why I chose Hohoi was because mostly the Volta region has one of the highest prevalence in terms of malaria cases. That's what actually inferred the choice for Hohoi. So I'm not really sure about the dominance for the various species in terms of the regions. I could verify and get back to you.
Your mentor is here.
Yeah.
I'm not supposed to speak.
You're not supposed to speak. Okay, so you can contact the mentor quietly. Yeah? Sure. Answer. The one who asked afterwards.
Okay, so
You want to use the microphone. Because we are recording, it's helpful if you can use the microphone. Use the microphone.
okay, so patient. So in your slide, is there an age limit that you are using?
Okay, yes, there is. Individuals less than 5 years.
Why? Why didn't you go beyond 5 years?
Because these people are mostly susceptible to malaria as a result of lowered immunity relatively in terms of those who are greater. So that's why I chose that age range, those that are less than 5 years.
My name is Manuela Adams, and over the past 2 months I've been working with my mentor, Dr. Linda Eva Amwa, and we sought to monitor the prevalence of Plasmodium species in symptomatic children living in an endemic town in Ghana. And my presentation will follow this outline from the background down to the acknowledgement. Okay, how is malaria caused? Malaria is caused by a Plasmodium parasite that infects the human body. And the ecology of this malaria disease involves the human host and sometimes primates, and also female Anopheles mosquito. There are several species of this Plasmodium that is endemic in this part of the country, and the one with the highest prevalence is Plasmodium falciparum. We also have malaria, Plasmodium malaria, Plasmodium ovale, Plasmodium vivax, and Plasmodium knowlesi. It's also known that malaria affects really poor countries in the world, and the World Health Organization reported in 2015 that 212 million new cases are recorded every year, and also 429,000 deaths are recorded per child every minute. And it's a leading cause of illness and death in this part of the world. And the most vulnerable groups are young people and pregnant women. There's a geographical distribution of malaria in Africa. Parts showing the red color, and then the yellow color shows countries that are endemic and epidemic to malaria. My study site was Cape Coast, specifically Ewim, that's a suburb in Cape Coast. So now the biology of the parasite. An infected mosquito, female Anopheline mosquito, bites a normal human being.
injecting the sporozoids into the body. These sporozoids then travel to the liver cells, invade, attack, and then burst out as merozoites. These merozoids then go to our blood cells, specifically the red blood cells, and then infect it in an erythrocytic cycle. This cycle involves the lysis of the infected red blood cells and also reinfection of new red blood cells. A small fraction of these parasites then develop into gametocytes, that's the sexual forms of the parasites. These then infect the midgut and then travel to the salivary gland, ready to infect another person, inject the sporozoids, which develop from the gametocytes to another person. A person suffering from malaria may show these symptoms. We have headache, nausea, muscular pain and fatigue, back pain. The spleen may enlarge, the person may vomit, and may have sweats and chills. My justification for the study is that Genton et al. In his report stated that mixed infections could be a result, could be the severity and duration of the disease is dependent on so many factors and could be caused by mixed infection. If you have an infection involving Plasmodium falciparum and Plasmodium vivax, treatment of these disease may flush out only the falciparum, leaving the vivax, because the treatment of vivax comes with the use of drugs and another therapy. Yes. It means you need 2 more drugs to do it. And in my study, we sought to check the sensitivity of microscopy and RDTs used in malaria diagnosis. And we know that RDT and microscopy are the main tools of diagnosis in our clinics in Ghana. And these come with their own challenges. With RDTs, most of the RDTs on the market are HRP2 based, that's histidine-rich protein 2 based, that is unique to only falciparum, and so it's not able to detect other species. Now, with microscopy, it's discretional. Only some few people who are very good can detect other species using microscopy. And so we sought to use PCR, that's a technique that is more sensitive and specific to detecting other species of the parasite. My objective was to determine the prevalence of different Plasmodium species in symptomatic children living in an endemic town. And the specific one was to perform molecular characterization of Plasmodium species. My work had fingerprint blood dried on a filter paper. We took 2 discs, we punched out 2 discs of the blood sample, and then we extracted the DNA out of it using the Kilex method. I used multiplex PCR, that's speciation, showing the specific parasite species in there, and then we analyzed it using the gel electrophoresis 2% algorithm. And my image is off. Okay, we can't see it, but I have my ladder in there that shows the base pairs of the different Plasmodium species. The ladder shows 100 base pair that gives the calibration of what we seek to find. And in my cases, we realized that all the patients showed symptoms of, showed Plasmodium falciparum. We found only Plasmodium falciparum in our gel. Okay, and the size of the band is 205, that is indicated in there.
Can you go back? Yes, try to click on the red thing on the corner there. Probably it will come up. Yes. Yes, see. There's a picture. It's just
But it was a very good picture showing that. I was so sad it's not there. I could show it later though. Yes.
Let's go to the next slide.
Okay, so we recorded this using 2 different years. In 2016, we had 108 cases, blood taken from 108 sick children. And these sick children, after doing our PCR, realized that all of the species causing the malarious P. falciparum, means we found nothing like Plasmodium malari and Plasmodium ovale in there. In 2017, we had the same case, and it turned out that a lot of children turned up for their blood to be taken. So we had larger numbers. We had 120 people, and all of the samples had P. falciparum in there too. So the discussion is that the most predominant species during the 2 periods was Plasmodium falciparum, and there was absence of other Plasmodium species in the samples. And there were more cases, disease cases in 2017 than 2016. And I would conclude that falciparum is still the predominant species of Plasmodium in Ghana, and PCR remains the most sensitive and accurate means of determining speciation in malaria infection. And I also recommend that a broader study should be conducted to assess the prevalence of other species in other populations. Because Dinko et al. In their recent report stated that they saw different species of Plasmodium in some parts of Ghana. These are my references, and I would like to thank ARA, WG for this opportunity to undertake this project. I also thank my supervisors for their time and everything they spent on me. I would also like to thank Noguchi for giving me the opportunity to conduct my research, and I would love to thank all staff and students of Noguchi for their help. Thank you.
Very good energy. I didn't get where you recruited the patients from. You didn't tell us about the sample size.
I missed the sample
Okay. I mean, where and how many people?
A wing, the suburb of Cape Coast, and then we took 208.
Hospital based?
Yes. A wing health center.
Green is very bright. So as much as we want to make our slides very attractive, I think a fluorescent, I think the slides are good, but the color could have probably made it even more better. It would have been a much better presentation if you hadn't chosen green as your background font. So maybe your next presentation, you could probably get an A+ if you use some
PCR.
Yeah.
I would like you to walk us through it.
Okay. So with multiplex PCR, it's a technique or a type of PCR involving 2 reactions. So with the first reaction, we use primers that are specific to the Plasmodium species. Then with the second reaction, we put in primers that are specific to individual species of Plasmodium. So we put in the primers for Plasmodium ovale, Plasmodium malari, Plasmodium knowlesi, and others. So in the multiplex PCR, you use different primers to detect specific parasite species.
Ladies and gentlemen, I'm now Kylie IT from KNUST. I'm doing chemical engineering, and I'm going to do a presentation on converting plastic waste to electricity, which was my project topic for the research. So I'm going to go through my introduction, my problem statement, through to my references. So we know that we always see plastics around. Plastics are organic polymers that are made from carbon and hydrogen, and sometimes contain oxygen, nitrogen, sulfur, and so many other chemicals. And we see them all around us. There are two main types of plastics. We have thermocertain plastics and thermoplastics. And thermocertain plastics are the ones that, when cooled and dried, they do not change form or shape and are very durable. So we have examples like polyurethanes and epoxy resins. And then we also have thermoplastics, we also have thermoplastics, which are soft, and when heat is applied, they change form. And 80% of the plastics that we use are thermoplastics. And we see plastics all around us. Examples are polypropylene. We have polystyrene, which is also known as styrofoam. We have PVC, which is polyvinyl chloride. All these are examples of plastics, and we use plastics all around us. So many things we do, from our toothbrush, everything we have around us, bottles, rubbers for packaging, we have plastics all around us. So my problem statement, this is a sight that we would see in so many Ghanaian communities. When you walk around in a Ghanaian society, you see rubbish all over the place. Our gutters are choked. When it rains, the water has nowhere to go, so it causes flood. When you see that when the water stays in the gutter, it causes stagnant waters and it breeds a lot of mosquitoes. So this plastic waste results in diseases like cholera, malaria, diarrhea, and so many other things. And so plastic waste is a problem in Ghana. So there are conventional methods that are used to manage plastic waste in the country. And we have incineration as one of them, where the plastic waste is burnt. But we use fire to burn these, and so we release a lot of carbon dioxide into the atmosphere. And carbon dioxide is a greenhouse gas, so it causes depletion of the atmosphere. Incineration also releases a lot of furans and dioxins into the atmosphere, which are very toxic to the human. So incineration, though is a conventional method, or a conventional waste management method, is not a very good method. We also have landfilling, where the waste is buried in the ground. And we realize that it just hides the waste from our site, but it doesn't get rid of it. And we know that plastic waste is not biodegradable. It takes about 400 to 500 years for it to break down. So this process does not really deal with the problem. And we realize that when there are toxic materials in the landfill, when the rain comes, it seeps through the landfill and it causes leakage, which is very harmful. We also have recycling, which is another conventional method, but it's very expensive. The startup cost for recycling is very expensive, so not many companies are able to patronize it. And Ghanaians do not really understand what recycling is about, and so they are not able to patronize it or practice recycling. So the aim of this research was to convert plastic waste into electricity. This was because we have conventional methods, but what are we doing? Those methods we see bring problems. So we needed to find a waste to energy approach which will bring us some benefits in the end. That was why we converted the plastic waste into electricity. And my specific objectives were to find an environmentally friendly waste management method, to produce combustible fuel, to rid our environment of waste, and then to prevent the spread of diseases. So for my methodology, pyrolysis of the plastic waste. And pyrolysis is a heat treatment process where we apply heat to plastic waste at temperatures around 375 degrees Celsius to 400 going. And in pyrolysis, we do not add oxygen so that it prevents the formation of carbon dioxide, carbon monoxide, sulfur dioxide, which are very harmful gases. So pyrolysis converts plastic waste. When we take plastic through pyrolysis, we get 3 different products, which are pyrolysis oil, which is sometimes treated to form diesel, and then we also have hydrocarbon gas, and then we have char. So in this process, we pyrolyze the plastic waste at 800 degrees Celsius so that we can get a lot of gas. And then we bet the hydrocarbon gas from the pyrolysis in the combustion chamber of the boiler to heat up the boiler to produce steam. So the steam is used to turn a steam turbine and then turn a generator to produce electricity. So this was my setup for the experiment, and we had the inlet. You cannot see the color, this very well, but then that was a burner that we used. And so this is the pyrolysis reactor, and then the pressure gauge, and then the pressure valve, and then this is the boiler, the inlet, and the other components. So for my results and discussion, in this process, okay, so here we're testing the gas that we got. It's not very clear here, so I'll take it to the next slide where we can see it properly. So we wanted to be safe, so we lit the paper and then we took it to the inlet of the pyrolysis reactor to test for the gas. I'm not done with the project. We are yet to produce the steam to convert it to electricity, but this was to show that this is actually possible. We can produce the gas, which we saw was very combustible. It's 90% flammable, so it can be used to heat up the water and then further to generate the electricity at the right pressure if we get that. So the aim of the research was to convert plastic waste into electricity via pyrolysis, and as I've already said, more time will be invested when I get back to school. I'm still not done with the project, so with the help of my supervisor, Dr. Jerry Ponyo, I'll be continuing the research. So for my recommendation, I recommend that a researcher should be able to put together the components of the process. For my process, I had a reactor and a boiler. So someone should be able to find a way to put this together into a plant like we have for a generator, so that we can optimize everything. So that if we have this in our homes and industries, the people do not have to manually operate it, so that we just input the plastics and then it comes out giving us the electricity. And the plastic should be able to, the plant should be able to have a way that it can gauge the level of the plastic that is inside and know when to start the process. And it should also be able to store energy for times where we will not always put in plastic. I also recommend that even as plastic waste is being solved, organic waste makes up 20% of the waste that is generated in our country daily, with plastic being taken as 19.9%. So organic waste and paper waste, glass, all that, something can be done about it. Can we generate electricity or energy from them, useful energy from them? So I recommend that a new way or a useful way should be found to generate electricity or any useful form of energy from these. So I'd like to thank God first and foremost for bringing me through the program, Araw Ghana for putting me on this program and giving me the opportunity to be a part of this program. I would like to thank Dr. Jerry Bonyo for everything he did for me, guidance throughout and his supervision. And I'd also like to thank Mr. Tuteria and Mr. Francis of the KNUST Mechanical Engineering Lab. They helped me with the construction of the prototype. And I'd also like to thank my family for their support.
Okay, thank you kindly. I want to know, in a country like Sweden, they were able to convert plastic into electricity, and it got to a particular time where they were actually paying the citizens to use up electricity, and then they even went ahead to ask other countries to import waste to their country so that they can use it for electricity. And when you got your recommendation, you were saying that there should be a way of putting some components together in order to facilitate the work you are doing. I want to know if you have read anything on how Sweden was able to do that, and if you can apply that to the work you are doing.
If I can apply what they are doing, the components, I don't really get you, but then the components, you see, from my setup, everything was standing together, so we had to input the waste, and then we take it through the boiler, we put in the water and everything. But what I'm talking about is something sort of a generator. You see how a generator works? You just turn on the button and then everything else works. So that is what I was talking about. I don't know if you got my point, but in Ghana we see a lot of waste around. So coming to what you're saying, importing a lot of waste, I think that there's so much waste around that we will not need to import any other.
Sorry, I was supposed to say export. They export the waste into their country and then they use it to generate electricity for the people.
Okay. Okay.
So I was saying that in your work, is there a way of you should try it and learn a little bit of what they are doing and then apply it to your work, and then maybe we don't know, it might be taken to the industrial level.
Okay. Thank you.
Thank you very
much.
So please, for those who are grading, she did less than 2 seconds less, so she actually made the time.
Yes, so I think this is a follow-up to her question. Your recommendation, you talked about a researcher putting things together so that, we kind of adapt your work. So I wanted to know if you can be that researcher.
Yes, with time. I'm going to continue with this, and I hope that with time I'll be able to get to that point where.
I'm sure everybody has a social media platform. Don't just post your new hairstyles, whatever interesting stuff that is going on. You don't have to put all your ideas there, but you should spark a conversation that will bring up productive suggestions for whatever you want to do. Because this is so cool, and this, like, if we have this as a major industry in Ghana, most of our problems will be solved. The flooding, the lack of electricity, people can cholera, malaria. It's a solution to a lot of our problems, at least what we talk about in most of our research institutions. So, thank you.
Hamid Elham, and I'll be presenting on smart waste homes, a new method of redefining waste management in Ghana. So this is my outline. I'll give an introduction. I'll get my materials and methods, then finally my references and acknowledgements. So when you talk about smart homes, it's a way of remotely controlling electronic appliances within the household. You can see from here, you can control your lighting, heating, and everything within your household. This technology that's recently gaining a lot of attention. It's been around from the 1960s and has been going with development for a while. And we know waste management is the method of the process waste goes from generation to disposal. And this whole research is aimed at utilizing the concept of smart homes to aid in the management of waste in Ghana. So my justification is Ghana has a very huge problem when it comes to waste management. We see them on our streets every day. Plastics, all the different kinds of waste. This research is aimed at finding ways to reuse all of them. And about 80% of the waste generated in Ghana are from households. So if we are to find a long-lasting solution, it should be able to target this problem from its roots, which is our households. The reasons for this problem are diverse, but the major ones is lack of deposit sites and poor sorting of the waste from recycling. And this has led to a lot of problems when we come to our social lives. Our social lives, environment, economically. There was this recent thing where Saturdays were left for general cleanup exercises. This is affecting our economy because instead of working, the traders are spending time working on this waste problem. Our environment, recently countries there's been this green awareness where they are taking care of their climate and environment, but there's nothing in Ghana here. We are not hearing anything much about it. So this is something that will be able to tackle this problem. So this is a common thing we see in our homes. The bin with all different kinds of waste in it, not sorted out, all crammed out, even pouring off. And this is the problem. When it gets here, I don't think there's not really much we can do. Apart from the recent innovations where all forms of waste are used to produce biodiesel and everything. But most of when it gets here, I think it's really sad because you see young people, young children here, they are scavengers and they are sorting out the waste for people to buy. And when in a way they are helping us because they are helping us sort the waste, but who takes care of their health? Some of the diseases and things they pick up from places like this. So the major thing is preventing this from happening in our society. So my aims and objectives is to create a new type of smart housing, especially tailored to suit the Ghanaian society, to minimize home operation costs, improve comfort, simplify the use of technologies, recycle, reduce and reuse all forms of the waste, and not just produce a temporary solution, a long-lasting one that will last for a really, really long time, and to stop all this negative impacts on our economy, environment, and social lives. So my materials and methods, I read books, I looked at other research work. I went to, even though it was aimed at the whole, my design was aimed at the whole Ghanaian society, I can't go everywhere. So I targeted Bokrom and Kumasi. I went there and I interviewed the people, I took information, I went to the dump sites, I collected waste for 3 days and sorted them out and drew graphs and everything. And I carried out some lab work where I created a model house of my design, what I'm looking at in the future. I also created a mobile phone app which I named iHome. Yeah, I actually wanted to come and run it here, but in order to do that, I would have had to carry my model house here and use it to control it for you to see, which wasn't very possible. So here, after collecting the data and running the samples, sorting out the rubbish, weighing them in my calculations, this was the percentages I realized. You see the, we can't see. Okay, so you realize that the organic waste is the purple one, the most generated form of waste. You see the plastics were the one following, then the paper and the metals, which weren't like produced a lot. So I found ways to reuse all the different forms of waste that was generated. Here is the biomethanation plant. This is our normal sewage tank at the house where when we flush and it goes into the digester. Then here the processing is undergoes some processes where it produces the gas goes through the gas outlet, and as it goes in, the pressure pushes the effluent to go into the overflow tank. in other processes or other countries, they burn that to produce electricity. But it was kind of joint between I and Kylie, so she was handling the electricity aspect. So, but it can also be used as compost because the microorganisms in it is very good for the soil. I created a model in my lab. It was just a small setup. Then another portion was the organic waste, the food waste, and I created like a bin, a specialized bin where it undergoes vermicomposting. There has been recent studies in it, and it was quite unfortunate that I wanted to culture the worms for it, and I couldn't even get the culture on my campus. But I'm still working on that. I'm not done yet. When I go back, I'll continue the whole process. But this bin is specially designed in such a way that the waste comes automatically into it. The whole system is run automatically, and when it comes in, the worms feed on it, and after a while, when new waste comes in, it's like moving from to fairer grounds or greener pastures or something. When it comes in, they go into the new waste, then you are able to harvest the one they have decomposed, and the cycle goes on and on its own. And also the grey water cycle, you can see here, all the water from the basins and washrooms and sinks are collected into a major outlet here, and it goes through a process where it passes through a sand filter, and after which it goes through chlorination, and it can be reused around the household. Another one is the paper recycling. Paper wasn't really part of the larger quantities of waste that was produced, but a process was designed for the paper waste too, where it goes through a grinding process, it goes through where it's then through, it's put into, it can either be bleached to make white paper, or it won't bleach where you can get like brown paper. Then it's sieved and dried into the sun, which is very good. Our climate is tropical, and there is no way you go and buy sunlight or something. Okay, so the other forms of waste, the glass, metals, and textiles, they weren't really produced in large quantities. And when I read or I went through a study written by another a graduate student at KUST, he wrote on metals. It was a source of revenue for the country. They were exported. And even I went to KJTR, and there was like a portion of the market specially allocated for this, and the glasses too. They had ready markets for it. And when I asked the traders where they get them, they go and pay people to go and scavenge on the dump to pick up these things for them. So you realize that the market is there, people are willing to buy it, but the main process is the sorting out. So my smart home addresses this problem of the sorting out. They're specially designed coded bins where these particular forms of waste are put in, because they actually require complex processes to recycle them. So the problem with them is the sorting out, which specially coded bins cater for. So my results were, I was able to determine the household waste composition due to my interviews and my research and data collection. I also did a survey when designing the application to know the commonly used household electronic appliances, because I wanted everything to be remotely controlled. You sit in your kitchen or you go to the market and remember you didn't put off your lights, you just use your phone to control that, and it's very easy because it uses like Wi-Fi. I also built a home automation system, a Wi-Fi based home automation system using a Raspberry Pi, an ultrasonic scented bin which automatically empties itself using a programmed Arduino board, and an Android application which I programmed using Java to ensure energy efficiency. So in the end,
your time is over, but just a few minutes to run.
Yeah, a biodigester especially tailored, designed vermicompost bin, and a water filtration system meeting the WHO standards. So yeah, basically that's how the system works. And in 2015, about 150 people were killed in the Accra flood. And when you go and look deeply into it, you realize it's all kind of race related. They choked gutters and everything, which didn't allow the water to flow caused the flood, which in turn killed so many people. And when it comes to waste management, a lot of problems. Someone did a presentation on malaria. I believe in prevention instead of cure, and this is the perfect way of preventing something like this. Deaths and cases of cholera, which isn't a problem in other countries, have been recorded like almost yearly in Ghana. So waste management through step housing is a very laudable concept, and it is the next logical step in the moving world order. We are moving to a time where everything is technologically inclined. We use our smartphones for everything. There's no one who doesn't use. These young children nowadays, they even know how to use the smartphones.
For presentation, and your work is very loaded. This is waste management at the domestic level. Yes. So at this point, can you just forget about the slide and just probably in 2 minutes or 1 minute, just tell me exactly what you mean by your smart housing?
So this is just like our normal homes, the homes we use, but it's been designed in such a way that everything we use in the household, we find a way to reuse or reduce it, so that the waste, most of the waste generated in Ghana is from households. So this is like targeting that we are going to reduce the waste so that it doesn't even pass the household stage where it goes to fill our land, our dams, and our land, and spoils our air by air pollution.
So how is your application going to help us do that?
So what the application, the whole system, the whole house will be automated, and what it does is we have color-coded bins in the kitchen in my model house, and you kind of put the waste in, it empties itself, it runs through the systems I showed, and apart from the other ones where I told you the main problem was the sorting out. This can even be a source of revenue because someone can decide to sell them. When I went to the market, it was like a hot commodity, and people were willing to buy them. So that's how the whole system works.
I have a comment. Talk about education. So you having a smart house with color-coded bins, if people don't decide to put in the right item in the right bin, then it's all, it's useless. So I think the first step to even getting to where you want to get to is to start by education. It's not going to cost much to educate people and to tell people how to dispose of waste or different types of waste, and then it makes work easier. So in as much as we are looking for that ideal situation where we have a smart house that you're all the way in the market, and then you're it's a little bit far-fetched. You need to be in a certain proximity before you can even operate, and so let's start with education, let's start with color coding bins, and then getting people to sort out waste. Then we move into high-tech. Thank you.
Thank you very much. Interesting. In my own house, I do sorting out as well. But when we started, it wasn't easy. Sometimes you have to go and pick out somebody still dropped something. But now it's fine. Everybody, it takes a while. I do agree. It will work. Yes, any more questions?
Thank you very much. I was about to mention it, and it was mentioned. I wanted to ask the problem of waste management. I think it's something with education, because even on Tech Campus, we have colored-coded bins, and still educated people are not able to do this thing. So I believe that waste management in Ghana, when we take the route of education, I think we'll be able to achieve more.
I'm going to do everything. State, government, I just want to see my idea. It's really nice if you see something you've worked on being used and having the impact. So what I'm going to do, I'm not just leaving it. This is something I'm going to continue working on. I might even it's something I'm really passionate about. So I'm going to take it everywhere really. In the end, you might come and use it.
You see her as a CEO of an organization that is carrying out exactly that. Thank you very much. Let's do that one together.
Very interesting.
Very interesting. Because of time, we will have to move on. Yes. So we'll take our next. Let's go on.
Our next presenter will be doing something on the antioxidants and anti-proliferative activity of Moringa lucida on breast and prostate cancer cells. And she is Elikem Kisa.
Her mentor is Dr. Regina.
Good morning. It's my name. Good morning again. My name is Elikem Kise. I'm a student of KNUST. I study biochemistry. And over the summer, I spent my time on doing a research on the anti-proliferative and antioxidant activity of Morinda lucida on breast cancer and prostate cancer cell lines. So, cancer is a generic term that classifies diseases that can affect any part of the body. It is characterized by the abnormal growth of cells, and these cells don't only grow abnormally, they grow relatively faster than normal cells in the body. And apart from that, they can also undergo metastasis, which is spread from the organ that they are initially affecting to other parts of the body. Cancer is, in 2004, it was cancer was recorded to cause 13% of the total deaths in that year. And then according to Globacon, 14.1 new cases were recorded in 2012, and also out of that 14.1, 8.2 million deaths were recorded. In Ghana, using the AIDS standardized rate, 91.7 was recorded for all cancers, and 63.6 recorded deaths. And prostate cancer and breast cancer are the leading cancers, like respectively. So prostate in men and breast cancer in women. And these are the occurrences in Ghana. The incidence, this was in 2014, in breast cancer, 25.6 incidents was recorded, and then there were 13.0 mortality, and then for prostate cancer. Okay, so for the treatment options, since it's such a big problem, there are several treatment options. We have radiotherapy, surgery, immunotherapy, hormone therapy, and chemotherapy. So over the years, talking about chemotherapy, over the years, plants have played a huge role in development of drugs for chemotherapy, and some important antioxidant agents like taxols, vinblastins, and vincristins have been derived from plant sources. One of the plants that have been found to supposedly have anti-cancer activity is Morinda lucida. It is found in the tropics, and it contains extracts like tannins, flavonoids, and anthraquinones. And this is a picture of the plant and its leaves. Now my justification. Prostate cancer and breast cancer are the most prevalent cancers occurring in Ghana. Now there has been, there's evidence in herbal medicine that this plant has anti-cancer activity, but not adequate scientific work has been done about it. So that's why I chose this topic. Now my objectives. Now my main objective is to find the anti-cancer ability of the plant. And to do that, I have to find the antioxidant activity and then the anti-proliferative activity of the sample. So this is my method. First, I did the extraction from the sample Morinda lucida. I had an ethanolic extract and an aqueous extract. Then I performed 2 antioxidant tests, the DBPH assay and the FRAP assay. And then I did a test for flavonoids and then a cytotoxicity test to check if the sample really works on the cells. So with my results, this is the DBPH assay from the year. So when it comes to DPPH, we look at, to check if the sample is really working, we look at the EC50, which is the concentration at which the sample does 50% of its work. Now, with the BHT, which is the standard, I recorded a 0.04, but with my ethanol extract, having a 0.012, which means that it's even better than the standard, and the AQOS having 0.02. This, in the extracts, we saw that the ethanolic extract was showing better activity at a lower concentration than the AQOS extract. Then again, I did the second antioxidant assay with BHT as my standard again, and this time BHT was recording 0.09 and my ethanolic extract having a 0.8, which was high. And then as for my AQOS extract, the concentrations I took, even at my highest concentration, they hadn't done 50% of the work. So with my test of flavonoids, what you do is to check the flavonoid content of quercetin is a flavonoid. So using that, you are able to estimate how much flavonoid is found in the sample. And with 1 milligram per milliliter of my standard quercetin will have equal the ethanolic extract will have 3.5 at 3.5 milligrams per ml. It will have equal flavonoid content as the quercetin and 10.05 for my AQOS extract. And then this is the final test to check the cytotoxicity of my sample. Now, having curcumin as my standard, now here what we check is the concentration at which the sample is doing 50% of the work. So that's the IC50. My standard was recording 4.32, and then my samples were recording higher IC50s. Even for the ethanolic extract, I got 400.7, and for the AQOS, I couldn't get. It was above 1,000, which was the highest concentration I took. And then this is, the previous one was for the prostate cancer cell line, and this is for my breast cancer cell line, where, well, it worked, but eventually you have to take a higher concentration of the sample to do what the standard is doing. So, in conclusion, Moringa lucida has proved to have good antioxidant activity, but when it comes to the anti-proliferative activity, you have to take a lot of the sample. These are my references, and I would like to acknowledge Araw and the Department of Clinical Pathology, Dr. Ejana Opoapia, Miss Eunice Doche, my supervisor, and Abigail Anya. Thank you. Normally with the extraction, okay, as we could see from the result, you have to have, like, for the AQOS extraction, I wanted to see, because some of the phytochemicals may not be extracted using the water. So I did ethanol as well. because they have different polarities.
Yes, but I'm wondering why wouldn't you take, let's say, public chloroform and then public water? Why did you use ethanol and then water?
Okay, I just.
Yes, I was hoping that you would say that we have heard a lot of people are consuming moringa and stuff from moringa, and usually either people will use alcohol like ethanol to extract, or people will boil in water, and so you like to make the science from the practical. That's why you choose. So that's what I was thinking that probably you will say that.
I did read that.
Yeah.
I have a question. You kept on saying sample work. What did that exactly mean?
Sample work.
Yes. You don't remember yourself saying that?
No, you know, let me show you. I actually wrote that point also to ask you when you were.
You said it's
eventually you said it, but it's good. You said the samples were doing the work. Which work?
They were being active.
The IC, when you had the IC50, the prostate cancer work. You said it was doing the work. Which work?
Okay, they were the whole idea of the cytotoxicity assay is to kill the cells. So
we just want
the work.
We want them to tell you to use the right expression. If it's cytotoxicity, because actually causing cytotoxicity in human or anti-proliferation, whatever. Let's just write it so we don't confuse us. Thank you. Any more, please? I think there are more here. Thank you.
I just realized I have a question.
Well, they are recording, so it's helpful if you project your voice.
Okay. My question is with the IC50s. Once it goes beyond the standard, what does it mean? Does it mean the extracts are overworking in that when you use it on maybe a human with prostate cancer or breast cancer, it works in a way that can alter some other cells in the system, or does it mean that it's not really working well and that when you use it on a human it won't really work as you expect it to?
It means it's working, but at a higher concentration. But also that concentration might be toxic to other cells.
Okay, so is there anything being done about that?
That's in vitro work. I think.
Okay, thank you.
Can I make a follow-up question to this one?
Oh, yes, please.
What's the difference between EC50 and IC50?
Okay, in EC50, that's to check it's EC50. So the concentration at which the
what is
free effective concentration. Yes, and so for effective concentration, that's the concentration at which the sample is
the same way it's okay.
So it's
right?
It's preventing the DPPH from affecting the cells. Yes.
Local name for moringa usually wasn't used for when it comes to Ghana.
Okay. I think in tree it's called concroma or something. I couldn't keep it in mind. But then I know its English name is brimstone tree. Yes, and then in Western Africa is one of the 4 most used plants in herbal medicine.
For what?
Okay, you can, according to what I read, you can use it for malaria, cancer, and other like. It actually has a lot of benefits.
Good morning. My name is Amina Ibrahim, and I'm here to talk about the cytotoxic activity of Xylopia ethiopica on yeast cells. Cytotoxicity can be explained as the inherent ability of a substance to be toxic to cells its inherent ability to kill the cells. And from literature, plant materials are the most abundant natural source of cytotoxic agents. Xylopia ethiopica, the plant I used, is locally known as Shrentia. I don't know if I'm pronouncing it right, but that's the tree name. And due to its healing properties, the fruits have been used for pains in the ribs or chest, in the treatment of boils, skin eruptions, and other illnesses, and it is attracting attention for its cytotoxicity. Yeast cells have also been used as model organisms for studying human cells. They have contributed more than any other agent to be used to study human cell aging. And then cancer basically is the uncontrolled proliferation of cells, and the most common and used forms of treating cancer involve killing or removing the cells from the body. This is a picture of the fruit, Xylopia ethiopica fruit, and my justification for using yeast cells as a model. I couldn't get cancer cell lines to use, so I used yeast cells because they are eukaryotic, just as human cells, and also they have similar genes that control cell cycle, such as programmed cell death and cell division as in human cells. Plant materials containing certain alkaloids, diterpenes, and quinones have been used in the management of cancer. And one of the main constituents of Xylopia ethiopica is a diterpene known as xylopic acid. The scientific name is cori-19-oic acid, and it's a corine diterpene. So it's sensible if we would investigate its cytotoxic activity because it contains this corine diterpene. And also, main ways of treating cancer, which are surgery, radiation, and drugs, all have major side effects. So the quest for new and more effective drugs with less side effects continues. My main objective was to investigate the cytotoxic activity of Xylopia ethiopica on yeast cells. My specific objectives were to obtain the growth curve of yeast cells, to perform a cytotoxicity assay on yeast cells using an emulsion of Xylopia ethiopica extract, and I used the ethanolic extract, and then also to run SDS page analysis on the yeast cells treated with the extract, because I wanted to find out the possible pathways by which the Xylopia ethiopica exerted its cytotoxic activity, if there was any. These are the materials I used: the Xylopia ethiopica fruit, the yeast, which is local, or the local yeast. I got it from a brewery. Tetracycline capsules, Twin 80, Sabrat broth, Kumasi blue. The method: the plant material was extracted with ethanol for 3 days and concentrated. It was reconstituted as an emulsion when needed using Twin 80. The growth curve of yeast strain was obtained. The cytotoxic activity of Xylopia ethiopica determined, and SDS page analysis was run on the treated cells. For the growth curve of the yeast cells, we can see that there was the beginning of growth. Sorry, let me start. At the 0th hour, there were about 40,000 cells per mil, and then the growth started around the 16th hour and peaked at the 48th hour, and then there was a decline in the growth of the yeast cells. For the cytotoxic activity of Xylopia ethiopica on the yeast cells, first the yeast cells were treated with tetracycline only, tetracycline plus the extract only, and then there were cells that had no treatment at all. We can see from the graph that yeast cells treated with tetracycline only had the highest percentage viability, followed by tetracycline, and followed by the ones that had no treatment, followed by the ones that were treated with tetracycline and the extract, followed by those treated with the extract only. So the yeast cells treated with extracts only recorded the lowest percentage viability. My SDS page analysis: the protein bands were obtained for cells that were treated with tetracycline plus extract, and no protein bands were obtained for yeast cells treated with only the extract. I couldn't complete the SDS phase analysis, so I don't have an exact image of the bands to show, but I could only take a picture of the analysis and the gel that was used. We used precast gel for this analysis. From my results, it shows that Xylopia ethiopica was cytotoxic to the yeast cells. An application of 50 microgram per ml of the emulsion produced a percentage viability of 18.91%, while that without the extract had a viability of 36.63%. Yeast cells treated with tetracycline only recorded the highest percentage viability because tetracycline is an antibiotic and it's promoted cell growth. The results also show Xylopia ethiopica induces protein damage, and it's a possible pathway by which the extract exerts its cytotoxicity. An absence of certain vital proteins or amino acids could mean certain death of these cells, hence the reduction in percentage viability. My conclusions: Xylopia ethiopica extract, the alcoholic fruit extract, exerted a cytotoxic action on the yeast cells, and it also possesses cytotoxic activity, which could be exploited to develop an anti-cancer drug. These are my references, and I would like to thank God Almighty and also thank the African Research Academy for Women for this opportunity. I would also really like to thank Dr. Vivian Boama for her immense support and every other person who supervised my research. Thank you. Since the extract had the cytotoxic effect on the yeast cells, it could very well mean that it would also have cytotoxic effect on cancer cells or human cells. And I just used a model. So if it had that effect on the yeast cells, it could have that effect on this. Yes, it's a model. And the main basis for the research was because cancer is killing so many people.
Thank you very much. The only issue is that even with the cancer cells, you have a lot of, some of them not even working and so on. So it's really a bit far. So I hope that soon you get some cancer cells. Let's work together, right? And get some real cancer cells to work with.
Okay.
Yeah.
I have some cancer cells.
Yeah, sure. I have to.
I mean, very interesting. What are your thoughts about toxicity? Is it if it's just killing yeast cells, it's not necessarily a good thing. Maybe we're killing human cells,
Yeah.
normal human cells.
Yes, that is a very valid point. I won't refute that. But like I said, the main ways of treating cancer, whether or not they kill the normal cells, is the killing of the cells. That's the most important. So if it kills the cells, then we can also go further and research as to whether it has a specific target when applied to a specific organ, let's say in a body. So that could be further research or further work. The main aim was just to research on the cytotoxic effects.
Effects of it. Okay. Thank you very much. Very interesting. Yes.
To prepare something like a porridge for my son because probably he has an issue, he's not eating well. I think just the flavor or something of it will make, and of course he eats. So if this Quintia is having such an activity, then it means that probably I'm actually doing more harm than. How do you probably help me get over this?
Like I said, it's used locally in preparing foods, and we've already seen so many useful effects of this plant, like for the treatment of pains in the chest and everything. And the extract I used is very, very concentrated. And the ones that you use in the house, you're using the entire fruit, not just an extract. So even if the particular components that do have cytotoxic effects are present in the ones that you use in your house, I don't think they are there in concentrations that are harmful to you.
Thinking is not enough. Thinking is not enough. You know, you're scientists, yeah. Yes. So this is very interesting. But like she's saying, I think that we really have to be very it's good. This is an exercise. We have to be very careful how far we will take some of the things, and because you have to, even with site toxicity, and especially when you have something called selectivity. Okay, we want to select. We want to see how selective it is. So usually we want to use normal cell lines to see what does it do with the normal cell line and so on. But what you have, the reason why I'm just leaving you off, I have so many questions. I'm leaving you off because, I mean, this is a good, looking at where you're coming from and the idea that this was not available, this was not available, so I did this and I saw this. But I don't think that is something that should scare anybody, because even with toxicity, we have something called the selectivity and so on. We want to find out whether it does anything with normal cells at all. Because this is not a human, and it could be something else with the humans, although we use it as a measure of cytotoxicity. So I don't think people should be afraid to take a pregnancy. I don't think that's what she's trying to. I mean, I keep changing things. I don't think that's what she's driving at. Thank you very much.
So I have a comment, actually, and that's just to draw you to your methods or to how you carried out your experiments. I want to know, how did you control for the effect of ethanol in your extract on killing of the cells?
How did I control?
What was the minimum amount of ethanol you used?
When doing the extraction?
No, when actually performing the assay. So your sample was concentrated to what concentration in ethanol, and what volume did you use per microliter per mil of your yeast cells or something?
We put this 50 microgram per mil.
You dissolved it. Did you dissolve the extracts? What did you dissolve? What solvent did you dissolve to do the assay?
Twin 80. It was the extract was it was extracted using ethanol and then reconstituted as an emulsion when needed using twin 80.
Absolute twin 80.
Not possible.
Absolute twin 80.
I don't get this. 100%. Oh.
So the emulsion is because you have a water and, right? That's how you make your emulsion. So what volume of ethanol was in the twin solution, the water twin solution?
After the extraction, we evaporated all.
Good.
You didn't remember that, did you? Good.
Okay, because she didn't do that.
Okay. I think that's one of the things that you are missing here, is that a part that you didn't do. Just say that this part I didn't do. Then it's a continuation of a project. Okay. I'm going to ask you about it. Did you check the authenticity that was this type and so on? He said that.
I'm very happy to share with you the work I did during my 8 weeks internship at WACBIP in relation to an enzyme known as the activation-induced cytidine deaminase AID, and how its mRNA splice variants are expressed in Plasmodium falciparum infected children. Okay, so my presentation will run on this outline, and I want to start with my introduction. So malaria continues to be a global threat to us, and Plasmodium falciparum has been identified to be the cause of the severest form of malaria. And the AID, activation-induced cytidine deaminase, is an enzyme that is responsible for causing mutation in the variable and then constant domain of the antibody repertoire, leading to the diversification of antibodies in the body in response to Plasmodium falciparum. It has been found to initiate somatic hypermutation and class switch recombination, two processes that leads to diversification of antibodies in the body. But then overexpression of this particular enzyme has been found in malaria-infected individuals, and this overexpression has also been found to be part of the tumorigenesis of a cancer known as Burkitt's lymphoma, which is a cancer of the secondary lymphoid tissues in B cells. Okay, so B falciparum infections can actually induce overexpression of 8 mRNA. Now, alternative splicing, as we all know, is a regulatory mechanism at the molecular level, and Zalshin et al. In 2017, this year, okay, they found that this particular process of the AID mRNA splicing, okay, results in 4 common splice variants. And these are the splice variants. You can't really see them here, but then we have the full length, which is AID-FL. Then we have AID-delta E4A, which has part of exon 4 spliced out. Then we have AID-delta E4, which has all of exon 4 totally spliced out. Then we have AID-delta E3, E4. So the name suggests the particular exons that has been affected. So AID-delta E3, E4 has been totally spliced out in. And then we have the last one, which is AID-IVS3. With AID-IVS3, it has all the 5 exons, but it has some sequence inserted between exon 3 and exon 4, which may account for the band size of that particular splice variant. So there has been inadequate information on how this particular AID mRNA expression is regulated in response to p-falciparum. So for my work, I wanted to identify the AID mRNA splice variants that are expressed in response to p-falciparum. And in order to meet this aim, I wanted to determine the expression level of the splice variant in peripheral blood mononuclear cells, also known as white blood cells, in p-falciparum infected children, and also determine the prevalent AID mRNA splice variants. So for my method, I use a sample size of 21, and these are archive samples that were stored at the Noguchi Memorial Institute of Medical Research, already under study by Professor Gordon Awandari. Then after taking my samples from that institution, I had to do what we call a snap tour using a solution of phosphate buffet saline, and then I went ahead to do an RNA extraction procedure. And when I extracted my RNA, I used the Trisol Directol RNA extraction kit to extract my RNA. After doing that, I had to determine the concentration, the purity, and then the integrity of my RNA isolates, because they were very vital to my work. So in order to do this, I used the nanodrop machine, which is able to give me the concentration and then the purity of my RNA isolate. And then I did a gel electrophoresis process to determine the integrity of my RNA isolates, whether they have been disintegrated or not. Then I went ahead to do the qPCR of my samples, and during this particular process, I had to use a primer that is well known to amplify all the 4 splice variants at a go. Okay. Then after doing that, I did a nested PCR, and this time I used specific primers that are known to amplify the specific splice variants that are known. Okay, then in order to confirm my results, I did a gel electrophoresis to see if my splice variants were amplified during my nested PCR. And during the nested PCR, I used the amplicons that I had from the qPCR process. So these are my results. The first graph shows the concentration of the extracted RNAs that I had, and we had an average mean of 50 nanogram per microliter. Then for the RNA purity, we had an average mean of about 1.6, and we took 10 best of the RNA isolates to do further work. So, that particular diagram over there was supposed to show the PCR amplification plot to, yes. Okay, then we have the AID mRNA expression. So from that PCR process, we realized that AID expression in symptomatic p-falciparum infected individuals were higher than that of asymptomatic p-falciparum infected individual at a significance level of 0.05. Then we went ahead to, so these are the results from the nested PCR, we use beta-actin as a control, and beta-actin is a housekeeping gene, and it is well expressed, like it's always expressed in the body. So we use beta-actin to normalize the expression of AID in our samples. So this is the curve for the MELT curve plot for beta-actin only, showing that, oh yes, just one product was amplified. But we didn't stop there. We had to do a gel electrophoresis to actually confirm the results from the PCR, and we realized that all our samples were showing just one band each. Then we went ahead to do the AID mRNA splice variant amplification.
So Annabelle, you have 1 minute. Just about 2 minutes.
Okay. So this is the results from the gel electrophoresis showing the bands. Then we went ahead. We didn't stop there. We had to go ahead and then do the gel electrophoresis of the nested PCR, and here we have band size corresponding to the splice variant that are already known. And one interesting thing we realized was that AID IVS3, the band size of that particular splice variant has not yet been established, but here we saw bands that corresponds to that because of the inserted sequence between exon 3 and exon 4. But then we are yet to do sequencing to actually establish that fact. So in conclusion, I'll say mRNA expression in symptomatic P. falciparum infected children are higher than that of asymptomatic P. falciparum infected children. And then we found this band, and then we need to do sequencing to confirm our results. So I want to acknowledge ARA for this opportunity. Professor Gordon Awandari, my supervisor, Ruben Ayojani, my instructor, President Kulinda Latte, Work Big for funding, Isabella Ampo for my twin, and then family and friends. Thank you.
Okay, very good, very interesting. It's open for discussion. Let me take the first one quickly. I'll come back. Hopefully this time. You said 21 children, and in your conclusion, you virtually have concluded on 20. That is enough to conclude.
No, I would say I'm not concluding, but in the data I have is suggesting these results. I am not concluding yet, but then I believe we have to do further sequencing analysis to actually sequence the bands that we saw, and it may become finally conclude on that. But in the 21 samples are not enough. We have to do we have to increase the sample size.
The point I'm trying to make here, just for everyone to us, that when you have something like this, very interesting a thing like that, you already give the comment so nobody will ask you. So you know that you have 21. You say that this is what I'm based on the number that you gave. Okay. And then you already add your recommendation. That I think that further with us. There's nobody who asks you. So you didn't even have to answer to me. Thank you very much. Please, it's open for discussion. Any questions? Anything that you want to ask?
Hello. Honestly, I don't understand the word. Can you explain, like, in layman terms?
That's very interesting, actually.
Okay, so the enzyme aesthetic, okay, the activation induced cytidine deaminase. It's an enzyme that is known to cause mutation, okay, in our antibodies. Now, you know that antibodies are responsible for fighting off antigens in the body. This particular enzyme has the potential of, let's say, you know the immunoglobulins, right? Let's say we have IgG, sorry, okay.
2 minutes to talk to a layman. Assume, I'm not saying she's the woman. Assume she's a layman. To help us to understand what you mean.
Okay, so these antibodies, when they are produced in cells known as B cells, okay. Now these B cells recognize specific antigens and then they fight them off. Now this aid has the potential of making the B cells have a higher binding attachment to the antigens and then fighting them off. So what I wanted to do, when I say alternative splicing, you know a gene, okay? The central dogma theory says that when you have DNA, it is transcribed towards RNA, and then you have a protein. But then alternative splicing may end up maybe having a gene that codes for multiple proteins, okay? So in the process of splicing the mRNA of this particular enzyme, which is proteinase, okay, you end up getting 4 splice variants that may produce what the AID protein, but then these AID proteins may or may not have good ways of causing the mutations in these antibodies to fight off the antigen. So that was all that I was trying to do, to identify this splice variant.
Yes, I'm very happy that I'm listening to you with the passion and the way you talk. I mean, it's interesting. And when I was listening to you, I just came to my husband, usually that's his line of work. And so when if you are in trouble and you go and ask him about malaria issue, this man will talk hard and you are like, please let me drop it and move on to another thing. And I think I don't know whether that's probably what you want to do. You have the passion, the way you talk, that it's so technical. Honestly, I do not understand, but I enjoyed the presentation. And I mean, that's excellent. Congratulations, you did very well. So I want to know, what has this 8 weeks training, what has it done to you? And tell me your experience. At least that's not technical.
Okay, so working at WorkBabe has been very helpful to me. For example, we had this big conference where different scientists came from different countries. I had the opportunity to meet Professor Anne Morman. She's a woman who is actually working on this particular enzyme. So meeting her and how she was presenting and everything, it really inspired me. And then meeting all those female scientists, yes, and then I met this African woman too. She's working on developing vaccines for malaria. And from what she was saying, she's actually close to doing that. So I was really inspired. Working under the supervision of Professor Godin Awadari has really helped me. It has I have gained more knowledge from him. I'm inspired by his work, and then we've been Aivo, my friend, my everything. I'm really, thank you.
So those who had the infection, and how many were the control or the control subjects?
Okay, so all the 21 were infected with P. falciparum. But I was actually working on asymptomatic patients. No, sorry, symptomatic patients. And then my instructor was working on symptomatic patients. So, asymptomatic patients. So, I wanted to get more knowledge from what I was doing. So I asked him for 9 of his samples to actually look at the expression level of AID mRNA in his, and then compare it to mine, and then try to make a little bit of conclusion from that result. So that was what I did. I wasn't intending on doing that, but then I did that anyway. Thank you.
Good morning. I'm Eyim Olivia Vashti, offering meteorology and climate science at KNUST. And I worked on the topic, the effect of climate variability on maize production or yield, a case study of Ijura farming community. My mentor was Dr. Mercy Bedu, and my supervisor was Professor Leonard Kupiche Amekuji. So my report will go through this outline for my introduction, which includes the justification, the objectives, down to my references. So, to my introduction, we all know that agriculture is the main socio-economic factor in Ghana, and it's the backbone of Ghana's economy. It contributes about 35% of Ghana's GDP, and it generates about 35 to 40% of the foreign exchange that comes into the country. It also employs about 55 people, like 55 of the population of the country. And as we all know, climate is the average weather pattern over a long period of time. When we talk about climate variability, it is the way climate fluctuates yearly, above or below a long-term average value. And if you say a long-term average for a climate, normally we meteorologists use 30 years if you're talking about climate. So above or below that fluctuation of climate, that is what we term as climate variability. Climate variability can occur within a month, a year, a number of years, or a season. And it may be climate that it includes a lot. can be changes in temperature, changes in rainfall, changes in carbon dioxide, changes in ultraviolet radiation reaching the earth. A lot of factors include climate variability. However, it has been proven that variability in rainfall characteristics influences crop production more than the other climate variables that we have. And this variability in rainfall could pose a threat to food security in Ghana. It could also be a source of, it can increase drought in Ghana. It can increase drought episodes in Ghana. So that is what climate variability is in agriculture. And looking at our agriculture, I chose maize because maize is a very versatile crop in Ghana. Every part of the maize is important, from the cob to the tassel to the leaves. Every part of the maize is a versatile crop, and it is the most important cereal crop in Ghana. In fact, it's about 50 to 60% of cereals in Ghana is maize. So by the end of this study, hopefully, try to provide a pathway to improve the maize agriculture, maize production in Ghana, and also to boost the agriculture's contribution to the nation's GDP. So to my justification, as I said, maize is the largest staple food in Ghana. Even as we Ghanaians, we all consume maize, from kenke to aple to abolo to all the foods that we eat. And also, it contributes to poultry. 50 to 60% of the poultry feed is made up of maize. And also, in the brewing industry, those who do meda, the guys who do meda is made up of maize, and some other drinks are made up of maize. And it's also used in feed preparation for other livestock. Even the leaves, if you do a maize farm and you don't guard it well, goats and other livestock will come and chew them. So it's as a feed for livestock as well. But in recent times, that's been known, research has shown that the average yield of maize has been dropping, has been continually decreasing. From Ragasa et al., they show that research in Ghana reported a relatively low increase in maize yield of about 1.1% per annum. Which brings me to my objective. So my objective is to assess the impacts of rainfall variability on maize production in Ejura. And I chose Ejura because Ejura is the largest maize producing district in the Ashanti region. So to achieve this objective, we determine the onset of rainfall season for each year, analyze the correlation between the rainfall data and the production yield, and correlate the vulnerability assessment information with observed rainfall data. So methodology, this is about Ejura. It's the largest producer of maize in the Ashanti region, and it is the capital town of the Ejura-Sechi-Dumasi district. And also about 70% of its inhabitants are farmers, and the largest crop they farm is maize, followed by yam. And the district lies in the transitional zone of the semi-deciduous forest and the Guinea savanna zones, and has a bimodal rainfall pattern. The bimodal means it has two peaks, like with the rainfall season. It has two peaks that it records two high rainfall amounts in the year. So this is just a map of Ejura. It's located at the border of Atebubu and Nkranza. It's at the northern part of the Ashanti region. Continuing with my methodology, I did a face-to-face interview with the farmers. I asked them about, and I did a questionnaire. The questionnaire was in English, but the interview was designed in Twi because most of the farmers were not learned, so they wouldn't be able to answer the questionnaire. So it was a face-to-face interview with them. The interview was categorized under their personal information, general systems and practices, and assessment of farmers' adaptation to climate change. Yield data was also obtained from MOFA, Ministry of Food and Agriculture, and rainfall data was also collected from the head office, JMET. And with the methodology, the data that we had daily rainfall data for 10 years at Ejura. So we used Python. I used a Python script called JSTAF time series to because the way that the JMET brought the information, it was not workable. I had to transform it into columns that had date, the amount. We transposed them into a workable format. We used the JSTAF time series for that. And Python used to calculate for the total monthly needs for each of the years. And NuPlot was used to calculate for the daily rainfall amount for each of the month for each of the year, and the correlation between the rainfall amount and the crop yield was also found using Python. And these are some of the pictures. This is about 1.5 acre of maize farm, and these are some of the farmers that I spoke to. Now to my results and discussion. Some of the information from the farmers were that the best planting, there are 2 main seasons for planting maize. That's the May-June season and the August-November season. But the most used season is the first one. That's the May-June season. That is because there's consistency of rain during the first season, and also there's consistency of rain during the first season. And with the second season, there's no assurance that there will be consistent of rain. So most of the farmers use the first season. And the best planting period is from the 1st to the 20th of April for the first season, and the 1st to the 15th of August for the second season. Any later dates, the plant might not grow and it might wilt. And also, the plant has its highest requirement of water during its critical stage. The critical stage of every maize plant is its seed week, and if at the seed week there's no water, the plant will wilt and die. And also, the maximum number of yield that they've been harvesting recently is 5 to 6, but per old years they've been harvesting about 10 bags. And the average age of the farmers that I interviewed were 60 years, and the average years that they've been farming were like 10 years. I even interviewed one who has been farming for 45 years. So he says recently the number of bags per acre has reduced to 5 to 6, but in old times it was 10 to 11 bags of maize per acre. And there are 2 varieties of maize sown in Nigeria. That's the local type and the Obatampa. The Obatampa is the monetically generified crop, and that one has more resistance to water and high temperature than the local type. Yes, look, this is a contour graph of, this is the month, this is the year, and this shows the rainfall millimeters per month. Looking at January, this is a color bar. So looking at it, you see that January seems to be the driest month of all the 10 years. It's basically from 0 to 40 or 50. And mostly the onset is the first day of the rainy season. It might rain in January, but it's a false start. The onset is the day that the rainy season starts. So the onset might start from March or April. And if any later day, that means the plant might not, if they start at a later date, the farmers might not plant early, and to lead to less yield that year. And the earlier the onset, the longer the rainy season, and the later the onset, the shorter the rainy season. So if you look at 2007, 2009, 2015, the rain started early. But if you look at these years, they were practically dry. And also we said that at the critical stage is the seed week. So if you plant in maybe March or April, the seed week will be within May or June. So within this May or June, there should be enough water for the there should be enough water for the plant to be able to stand. So this shows all the various, with the color bar you can see the amount of rain per month, and this shows the amount of rains per year. This shows the yield for each of the year. With 2009 recording the highest yield, that's 2.5, and this is the graph of the crop yield and the yearly rainfall. And the correlation of this graph is 0.46. With the correlation, we can see it's 0.46 because there are other factors. There are other factors that results to the good yield of maize, not just rainfall. But 0.46 means that it's very high than any other factors that affect maize yield. So in my conclusion, I'll say that for a good maize yield, there should be a higher amount of rainfall spread over a higher amount of days in a year to be able to get a higher amount of rainfall. And in my recommendation, I would say that more research should be done to include all the other factors, that is soil fertility, temperature, application of fertilizer, pest infestation, to be able to create a model that if you input these values, you get the amount of yield that will be produced in a year. And also, GMET should also provide a forecast of the onset and the duration and also the cessation of the rainfall, so that farmers will know when to plant their farm and how the season is going to be like. Also, there should be irrigation policies that should be implemented to supplement when there's no rain or when there's no moisture, so that the plants won't be deficient and will get water in replace. And also, there's certain farming practices such as land tillage, mulching. Mulching will be able to retain certain soil moisture in the soil so that they all won't evaporate. These are my recommendations.
I was very happy you mentioned, you acknowledged other confounding variables that may have affected the percentage yield. My question is, so far from your work, when you were getting to the end, it was like you were rushing because of time strain. What's the trend that you actually saw in your work? You took a 10-year period. Okay. So what's the percentage yield against the percentage, the rainfall? That's my first question. Then the second question is, are the farmers justified by, are they justified to wait for like rainfall before they actually plant, or do you get my question? All right.
For the percentage with the crop yield and the rainfall, I did the correlation coefficient, which I mentioned to be 0.46. And I said it is so because there are other factors that contribute to the maize yield, but 0.46 means it's higher than all the other factors that contribute to it. And yes, the farmers wait for the onset of the rain before they plant. That is why in my recommendation, I recommended that GMS should let the farmers know the day of the onset so that they can plan on how to plant their crops. Thank you. Climate is not stable. Climate doesn't have a trend. Anything can happen at any time. So with the trend, as I said, the onset is needed because you can't say whether the onset will be today or tomorrow. If you know the onset, know that this year the rains will be longer. If the onset comes late, you know that this year the rainy season will be shorter. So climate doesn't have a particular trend it follows. It fluctuates. That's why it's climate variability.
So as a meteorologist, when is the next farming season?
Next farming season.
Farming for Ghana.
Farming.
Yes.
Oh, okay. Please, I'll have to confirm from James. I don't have any data to predict that yet.
You don't have enough.
Yes.
How we put our house together?
Thank you very much. My name is Louisa Koba, and then I'm a food science and technology student in KNUST. I'm presenting on the microbial quality of cabbage and ready-to-eat vegetables across the food chain. Okay, so this is my outline. I'll talk about my introduction, my problem statements and justification, aims, objectives, materials. You can see everything. Yeah, so my introduction, we know that vegetables are very good sources of vitamins. They have dietary fiber, and then also they provide us with minerals. And then vegetables also contains phytochemicals and polyphenols or phenolic compounds which help fight mutants in the body. They serve as antioxidants, and so they fight mutants and then free radicals in the body, thereby helping us prevent chronic diseases. Also, vegetables are very high in moisture. And then when we talk about the cabbage is a cruciferous vegetable, and this vegetable has very high moisture content, and so it provides a suitable environment for microorganisms to thrive. Then the ready-to-eat vegetables, when we say ready-to-eat vegetables, they are minimally processed vegetables like the salad. They are chopped, like mixed vegetables that are chopped and ready to be served to others. Microorganisms are almost everywhere. As we sit here, microorganisms are just roaming about everywhere. We can't see them. And then we have different types of microorganisms. We have pathogens, we have spoilers, and we have beneficial microorganisms. The pathogens are the ones that cause diseases, and then the spoilers are the ones that cause food spoilage. And then we have the beneficial ones, those that are used in food production, like the yogurts. We use the beneficial microorganisms. And then microorganisms can cause food poisoning if if the food is not really kept well, and they may be naturally present or can get into the food through improper handling. My problem statement and justification. Eating habits have changed in Ghana in recent years because in the past, people mostly go to work and they don't really spend most of their time there. But due to our economic structure, our systems, how our economy is going, most people spend most of their time in the workplaces, and so they rely solely on these food service establishments for their feeding. And these food service establishments have included, most of them have included salad and these vegetables in their meals. And so to meet the needs and the demand from these workers, they are not able to concentrate on how to keep the vegetables well or how to prepare their food in a good way. They are so minded about providing their consumers with what they want without thinking about the safety of their consumers. Also, foodborne illnesses related to the consumption of contaminated raw or partially processed vegetables have been increasingly high. That was a work done by SU and Araw. And then this is a result of bad farming practices on the part of the farmers, and also improper food handling on the part of the food vendors, and then also poor personal hygiene on the part of food vendors and also the consumers. My aim and objectives. The aim of this study was to assess the microbial quality of cabbage and then ready-to-eat vegetable across the food chain. And the specific objective was to determine the total aerobic mesophiles of cabbage and mixed vegetable salad, to determine the total coliforms in cabbage and mixed vegetables, and then to isolate and identify any enterobacteria present. This is my methodology. So my sample collection, the samples were collected from 6 different places. I went to Hacho Farm to get the cabbage. I also got the cabbage from the UG farm, and then also vendors at the 9th market. And then for the salad, I bought salad from restaurants on campus, Tasty Treat, and then also Basement. And then I bought salad from the Wache seller at the 9th market at the UG. And for the sample preparation, the samples were worked on that same day they were purchased. And when they were purchased, they were kept in sterile bags and then kept in ice chest so that it will not affect the results. And then with the sample preparation, we weighed 10 grams of each sample into sterile stomacher bags, and we blended using the stomacher blender to get a solution. And then we did serial dilutions with it. We did the dilutions in PBS. And then with the serial dilutions, we transferred some of the serial dilutions on plates for the microbial analysis. We did total counts on PCA, that is pour count agar, and then we also did total coliforms. We enumerated total coliforms on the violet, red, bile, glucose agar, and then we also did isolation, and then we wanted to detect some enterobacteria, so we did streaking on McConkey agar and then Salmonella shigella agar, and then we performed biochemical tests from the colonies that were gotten from the McConkey agar and the Salmonella shigella agar. So we performed biochemical tests, and then we did further biochemical tests using the analytical profile index to confirm the organisms. So my results from the table, you can see UG had the least aerobic count, with Hacho Farm having the highest, followed by 9th market. And also from this table, you can see that the Basement salad also had the least aerobic count, with tea having the highest, followed by the salad from the UG 9th market. And then from the table, you can also see that UG had the least total coliform count, with Hacho Farm having the highest, followed by the 9th market. Also, here to the same thing, Basement had the least, Tasty highest, salad, and then salad from the UG Farm also followed. And this is a picture of the, this is the Shigella Salmonella agar, Salmonella Shigella agar, and then that's the McConkey, so that's the goat on it. So these goats were the ones we used for the biochemical test. So this is the biochemical test. That's a picture of, this is the TSI, triple sugar ion, and that's the Simon citrate. The indole is in there, you can't really see it, the same. So these were the speculated organisms we're speculating to be in there. So we did further biochemical test. So for the further biochemical test, we used API, analytical profile index. That's to confirm the organisms we had from the biochemical test we did. And from the analytical profile index, we had very interesting organisms. From salad from the 9th market, we're able to identify Enterobacter sakazaki. The Enterobacter sakazaki, I read from literature, is an emerging pathogen. It was found in infant formula, and it's known to cause meningitis in infants. And then also it has a lot of death cases. It can also affect adults, but it's not really. We are not really at risk like the infants. And then also the Pseudomonas species. With the Pseudomonas species from literature, I realized that the Pseudomonas species, some of these species are part of the microflora of the vegetables, and so they are not really harmful. But we have harmful ones that can cause infection, but I'm not sure they are in the food. And then for the 9th market cabbage, we also got Pseudomonas. And then from tasty, we had Escherichia adicarboxylata. This adicarboxylata is known to cause soft tissue wounds. Like it can cause some wounds. I don't know how the wounds come about, but that's what I saw from nature. And it's similar to E. coli. So most people confuse this particular organism with E. coli. So if you don't do further biochemical tests, you might think from the growth you see on the maconche that is E. coli, but it's this organism, and it's very deadly. And we also isolated Klebsiella from this. Klebsiella is also a pathogen, and it causes infection. And then we also found E. coli from it, and the E. coli was in the basement salad. And
now you have 1 minute.
okay. So my recommendations and conclusion. So from the study, based on the study I did, I realized that we must not look at the outward appearance of the vegetables we buy, because the vegetables I bought were very neat and very clean. They looked very good, but when we ran the test, we had a high microbial load. So the next time you buy a vegetable, don't look at the neatness or anything. Make sure you wash it with vinegar water, or if you don't have vinegar water, wash it in salt solution. And I would like to acknowledge Araw, Prof. Dorothy Eboamenu, my mentor, Mr. Lorenzo, the staff of bacteriology, my family and friends. Thank you very much.
Very insightful. I believe everybody learned something.
Yes, especially those who are tasty and so on. Thank you so much. Yes, the first hand. I think there was the hand. Do we do ladies first? No, let's give them this.
So, thank you very much for your presentation. And I could see a big worry on the face of our Ndari. Because he has a favorite place where he eats lunch from your presentation. And I think that next time if you are doing this presentation, if it is possible, code where you are getting your samples from. Okay, if anybody wants further information, that person can talk to you. If Tasty and people were here, they can see you for it, because you didn't ask permission from them to do that.
So for great presentation. So as a food science and technology, okay. Now that you have found this, what's the way forward? What's the way forward?
Okay, so in following this result, we realized some interesting pathogens were isolated, and then I cannot based on this work, because we just use few samples, so I'll try and then do further work with more samples, if we can go back and then get more samples from different places, and then also assess those farms, because I realized the cabbage from Hacho farm, it was very, if you see it, you think this is very good, but it had like very high loads of microorganisms inside.
In your conclusion, you talked about the fact that when we buy our vegetables, we should wash it well, and you mentioned vinegar. So did you do any controls, washing some with vinegar and then testing?
Okay, with my work, I didn't do anything on vinegar, but works that people have done. I read literature and then work done in Nigeria. They worked on the vinegar one, and they realized that when they wash the vegetables in the vinegar, it reduced the microbial load to 3 to 6 log CFU, and so it reduced it very well, like 3 to 6. So it was very good.
We'll take this and then probably this one burning one. Otherwise, the rest will be discussed because it's going to be lunch. So you can talk about lunch.
Louisa, did you find out from your farm where they pick water to water these vegetables?
Okay, for the Hacho farm, I couldn't ask them, but like we saw, I observed the area before, and then you realize that where the farm is, in front of the farm, there's a very big gutter. It's like a river. So I think maybe that's where they get the water to water the vegetables.
Is there any question? Final question? Okay, thank you so much, Louisa. That was a great project. Next on our list, we have...
Please, we will collect the grades from those...
End of our internship program. It's been really interesting. Meeting 10 new ladies from all over Ghana, coming from different parts of Ghana, and working with them. It's been great. I mean, I've made another network. I've created another network with them, and I can go anywhere from the north down to the south to see someone there. It's been very good. I just want to congratulate all of you for having patience, for learning, for putting in your best, and then learning more. Because I think as a scientist, all we have to do is read and do a lot of research. Because our research work is what is carried out. Because I think before a doctor can even diagnose someone or prescribe a drug to someone, the illness has to be researched on, and then you have to test on how the quantity that's supposed to be administered to the person, and all this is based on our work as researchers. So I think we are doing very good. I want to acknowledge our mentors. I want to thank them for everything that they've been doing for us. They've been very helpful. They've been very, very helpful, because I can call on anyone at any time if I'm confused, and they're always ready to help me. And I just didn't have to face a lot of problems, because the girls didn't have to come to me straight away. They had their mentors there to support them, and it's been very great. I'm very, very grateful. Also, I want to thank our sponsors and our organization. It's been good, and I didn't have to be running up and down asking them to send me the money, or the money was on time, everything was in place, and it makes my organization very, very fruitful. And then my volunteers, how can I forget you? I can call Araba, someone needs a room, find the person in a room, because I can't do this part, and Araba will be there. Linda was always running from here to there. Jessica, where are we supposed to go? I'm very, very grateful. Helen, I need a summary of the report, and then she's already there. I need it by Saturday, then Saturday my email, the report is there. It's been good. I'm very, very grateful. And also, I just want to say well done, and then may you continue to do the science, because it's very good, and then it also takes you to another level. Now, finally, we've come to the end of our presentation, and work, and as an organization, I think it's a good thing for us to reward all those that did their best during the program. And it's time for that. So I'm sure, and when we're doing the presentation, we're grading you, because we have a reward for the best research presentation. So I'm sure the results will be out soon, but then we'll start sharing certificates for those who took part in the internship program. So the first person is Louisa Koba. her mentor was Prof. Dorothy Ebuamin from Nikuchi. Clarindata, and her mentor was Prof. Awandari from Bangladesh. Hamid Kuinwa, and her mentor was Dr. Jerry Konyo. The next is Isabella Fofu. Her mentor was from Awandari.
Please take a photo.
All right. Next is Elikem Kaiser. Her mentor was Dr. Regina Kialbo.
Don't take. Yeah, that's what I'm doing.
So next is Olivia Yin. And the mentor was Dr. Messi. Next is Hikmatu Hassan. Next is Aminat Ibrahim, and the mentor of Dr. William Mark. Evangeline Godai to come and present the next. Okay, the next is Na Okaile Aite, and the mentor of Dr. Jerry John Kono.
Can we see the certificates?
We also have certificates for our volunteers. So when I call you, you come for. We have Elizabeth Osei, who was at Kumasi helping out over there, but she couldn't make it today because she has to work. And then the next is Rodalyn Adi.
She was a mentor which year? Can you tell us? She was an intern which year?
Yeah.
Last year?
No, she's a volunteer. She wasn't on the program, but
has she been an intern before?
No. She came in from the US to help, and she's from Stanford.
Oh, she's the one who came from the US.
Thank you. And then Apishi. She's also at Kumasi.
Let's see the certificates. Let's see the certificates.
Then we have Patience Adekote. Certificates to the that's the certificate of completion. Next is for awards, leadership, and then overall best performing student. And for those two awards, we splitted it into the two campuses because we have people in Kumasi and people in Accra, and then they were working with different people and I wasn't there to see everything. So I decided to split the award up for the two of them. So for Kumasi, we have excellence in leadership. And the person who got it was Olivia Eyim. And she gets an amount of money, and then a gift as well. In Accra, Louisa Koba was the one who got it. Yes. And then overall best performing student was Mr. Bolampo from Accra.
If you didn't get a hat, sorry. I need to premeditate.
And then for Kumasi is Na Ukaile Aite. So we are still waiting on the best research presentation.
We have some tokens of money. And we have had very helpful coordinators over the years. And you can, probably those who have been with us again for a while will attest that Jessica has done a great job this year. And I think we want to put our hands together for her. Yes, I think, is it ready? Otherwise, we'll go and start eating. And we'll do that while we're eating. Yes. I think that usually we would have certificates for mentors, but we missed that. So next time we will try and do that. Okay. So we have we need someone who knows how to write this case. My handwriting is not, I cannot do that, but we'll do that for you. But we have the name already. Let me drop this and do that since it's in. For the overall best presenter. My biggest skills are coming. We have, you're all on Tintakus, right? We have Miss Isabella. So she's the person of Dr. Vivian Boama. Dr. Vivian Boama. We have
Thank you.
God bless you.
I couldn't have done it without my mentors.
Your masters, for your PhD should be something. You should make sure that it comes to stay. It shouldn't be that you just did it at Araw and it's the end. You can also take it to other conferences and present there, and through that you can get donations and then sponsorship to even further it. So don't leave it there. I just want to thank all of you for being very cooperative and having time for me. Maybe sometimes I wouldn't even have time to call you, but then when you have problems, you find it easy to come to me. I just want to thank all of you, Dr. Linda, Prof. Awandari, Dr. Regina. I just want to say thank you to all of you. And, I think we'll take our closing prayer from Dr. Mercy Beju.
Shall we pray? God, our Heavenly Father, we thank you so much for this afternoon. We thank you for the opportunity that we have gathered here as women in science, engineering, and mathematics, and we are learning to do the science to project the image of our country. Lord, we thank you for the strength and the grace that you gave to us, the mentors. We thank you for the life of our girls. We bless you, oh God, that you have brought us this far. We pray we commit our lives into your hands again. Even as we are living here, God, we are not leaving your presence. We ask that you go with us. Be with us even as we pursue the science. We ask that you will be with us, you will direct us. When we lack ideas, God, we ask that you bring ideas. When we have the ideas and we need money to accomplish it, we pray that you provide, because you are the great provider. God, we commit our lives into your hands, our parents and everybody who has been involved in our progress. We ask that you be with us. We thank you, Lord, because you are answer praying God. We thank you in Jesus' name. Amen.
I'm in my 4th year studying animal biology and conservation science in the University of Ghana. And I work with Araw, that's the African Research Academy for Women. It has been a very wonderful experience since day one. I was supposed to work at WACBIP, the West African Center for Cell Biology of Infectious Pathogens, where I got to do my project work entitled Detection of Plasmodium Species in Asymptomatic Individuals in Pawpaw Municipality, Ghana. And I got to find a lot. My findings show that Plasmodium falciparum accounted for 72% prevalence, and there was only one mixed infection with Plasmodium falciparum and Plasmodium malariae that accounts for just 2%. So it was a cool thing. I got to learn a lot. And looking at my background, animal biology and conservation science, I got the opportunity to be exposed to a lot of molecular tools and equipment. At the same time, learn a lot in terms of molecular biology. So it has been a very great enlightening experience for me as an individual. And I encourage our sponsors there to invest in Araw. It's a great initiative because it actually empowers women in research, and that's the reason why I joined Araw. Because of my interest in research and because of the objective of the initiative to empower women through research. And so I'd like to thank God Almighty and then for helping me throughout my entire 8th day at WACBIP and throughout my entire program. Thank you.
Hello, I'm Hamid Ilhan Kwan, a student at Kane University in Ghana. I was studying civil engineering, and I worked on smart energy homes, smart waste homes actually, as part of the Araw Research Academy program. So smart homes have been around for a while, like they've been used to remotely control lighting and heating in other countries. But my research was aimed at better utilizing the concept of smart homes to use in waste management, which is a major problem in Ghana. So doing research, finding the issues, how waste is generated, the forms of waste that are generated, I was able to create a design and a model home which will be able to cater for all the waste problems in Ghana. And being a part of this research has been really, really interesting and important. I realized, working on previous assignments, I realized how important research was in engineering, and it helps you get the broader concept of what you're working on. And this research really opened my eyes to a lot of things. And I believe Araw should be something every lady should be given the opportunity to be a part of. I'm very happy if a colleague or a junior classmate was to take part in it, because it's something that it's just helping you. It's a way forward. It's really a good innovation. Thank you.
Hi, my name is Epikem Kiseye. I am a student of KN University. I study biochemistry, and I was on Araw, the Araw summertime internship. I was interested in Araw because my cousin was on the program 2 years ago, and it sounded like a very good opportunity to have a way to project you into your future. This summer I had the opportunity to work at the Uchi Memorial Institute for Medical Research, and I worked in the clinical pathology lab where I worked on a sample, Morinda lucida, finding its anti-cancer activity on breast cancer cells and prostate cancer cells. Since research is a very important part of science today, I think that it will be very helpful if people came on board to help support women discover their potential in the research area.
My name is Manuela Adams, a student of K University and an agriculture student. I got to know of Araw through a friend, and it was really amazing when I was chosen to be a part of it. I believe that women have a lot to contribute to society. society, with how we live our lives, how we manage our things, And so if women are incorporated into the research area, would help in making things better and also encourage other women who feel so low and feel inferior to study science to also come up and do this. And I know that with Araw, I've gotten a lot of passion to go into research and find out more about what's happening in the world. My research topic was on the prevalence of Plasmodium species, that's the parasite that causes malaria in Ghana. And it's been amazing. I really thank Araw for the opportunity to be part of it.
I'm Hikmat Al-Hassan Khattari from the University for Development Studies, studying Doctor of Medical Laboratory Science. I first saw the link for African Research Academies for Women on the internet, and as my course already is geared towards research and finding solutions to communicable diseases, I got so much interested in this and I applied, and then I was fortunate to get picked. And doing my 8-week internship at the Mobutu Memorial Institute for Medical Research has really unleashed my passion in the research field. And also, Araw being in a governmental organization is how to help young females who are interested in research and then have passion for it. And being a fellow in the 2017 cohort has really unleashed my passion and also directed me towards the field I would like to enter when I'm done with my course.
Hi, my name is Louisa Koba and I'm a student at KMST. I offer food science and technology in third year. Okay, so why Araw? Well, I chose Araw because I saw it to be an organization that was meant to give me the platform I needed. Like I always wanted to do research in my area, and they gave me this opportunity, so that's why I chose Araw. And then women in the STEM, I feel a woman is very important in science. Pediatry once said that if you educate a woman, you educate a nation, like you educate a man, you educate an individual. So I believe if more women get into science, we are going to solve more problems in the world. Thank you.
Hello, my name is Nalfredi Aite. I'm a chemical engineering student from the University. My research was about converting plastic waste into electricity. I chose Araw because it is a very nice opportunity for me to engage in research, which is something that I really love, and it promotes women in Africa, which is a very brilliant idea. Women should be promoted to join STEM because we are quite large, and then so many women should be pushed into the field so that we are not all pushed to the background. Thank you.
Hi, I'm Eyimoliga Bashti. I study meteorology and climate science at KM University, and my project talks about the effects of climate variability on maize yield in Ijua, the farming community in Ghana. Well, why because it's a very good initiative which encourages women to go into science, technology and math, and women should venture into such because we are in an advancing world, and these are the basis of everything that is advancing. So if more women go into it, we can achieve greater heights than even the men and the guys. That's what I chose Araw. Thank you very much.
My name is Amina Ibrahim. I'm a student of Accra University and I study chemistry. I had the opportunity to conduct research on the cytotoxic effects of Xylopia ethiopica on the cells. And I chose Araw basically because it's giving me the opportunity of a lifetime, and I couldn't get this anywhere else.
My name is Isabel Ampofo, a student of the University of Cape offering BSc Molecular Biology and Biotechnology. So for my project work, I decided to study an enzyme known as the activation-induced cytidine deaminase that is responsible for antibody diversification, and I wanted to look at how it is spliced in response to Plasmodium falciparum, the causative agent of malaria. So for ARAW, I believe ARAW is founded on some core principles that define me as a woman. They are building link for scientific research purposes, and that is the kind of field I want to go into. So this program has really helped me. It has boosted my confidence level for presentation, has actually thrown more sight on research work, and I intend to stay in this field. Thank you.
Hello, I'm Jessica Santi, the Program Manager for African Research Academy for Women. This year has been very great, taking over this new position and grooming these girls to become great researchers. It's been smooth, and working with them has been very interesting. They've been very collaborative and they've learned a lot. Quite remember when we went for our community service, the way they even interacted with the girls in the Accra Girls School, it was very good. I believe that training these girls to learn more in science and not to give up their hopes in science is a very good opportunity for them.
I'm Linda Latte, the volunteer leader of this year's Academy. Indeed, I must say that working with the ladies has been interactive like this person, and it's been a learnable program, starting from their orientation to their progress presentation and community service, and today being their final presentation. We've all been educated on various topics on food, waste management, and in fact, it's gone a long way. And I must say that working with these girls too has also groomed me as a team leader, because it has helped me manage them and also improve on myself. And so I'm glad Araw gave me this big opportunity to serve them as their volunteer team leader.
I want to say thank you to all our sponsors. It's been good, and then the money you give in this program is not gone to waste, because I trained a lot of ladies. And also we look forward that you continue to input in this program so that it will become a better one, and then next year will be very great. Also next year Araw turns 5 years. Hooray!
Hi, my name is Araw. I was at Vincent from last year, and this year I volunteered in the summer internship program, and it was amazing. It was wonderful. I didn't know being a volunteer was actually going to be this amazing. I learned a lot of experiences from the girls this year, and it was actually exciting learning new things, because last year I was basically learning just one thing, that was my project, but then this year I got a chance to know the 4 girls that I was helping out at Sundoguchi, and I got to know everything about their project, and it was actually kind of cool. So working with Araw this year as a volunteer has been actually amazing for me, and I really like the experience I have gained, and I would never regret joining Araw.
Hello, I'm Patience Adekute, an alumni of Araw, a 2016 intern at Gucci, and the experience was very great, especially when it came to research. I got hands-on techniques on how to do research, especially in the lab, and it really helped me from school. This year, I decided to volunteer to help Araw with their 2017 fellows, and it has been a good experience so far. Reading their reports and trying to summarize everything they've written helped me gain more knowledge into what they were doing, and if I should say, saw things on in a different way. I should really put it. This and many other things we picked up from this year's intern. I wish to carry on and learn more about it. Thank you.
My name is Vivian Etiapapwama. I'm the coordinator for KNUST and the mentor as well. What I can say about the program is that it's been very good for a lot of girls. So far we've seen about 14 girls, or close to
So I have two, and I have two at James and your place, and I think
we had 8, and then this year we had 4. So a total of 12 girls passing through KNUST so far, and the lives of these girls have been impacted so much. So I would encourage every young girl interested in STEM, that's to say science, technology, engineering, and mathematics, to just give it a try when the opening comes. We try to disseminate it as much as possible. And then I know being part of the program, your life as a woman in science will change for the better.
Yeah, so I am Mercy yesterday, and then I have been a mentor since last year. So last year I joined the program, and then this year too I have been in the program. I think it's a very good program. I'm very happy for the initiative that somebody will think about girls in science, mathematics, engineering, education, and the fact that when this is projected in the area of research, it is going to better the lives of not only the girls, but in the community that they live in. If you look at the projects that they look at, they really pick community issues and they try to solve the problems. And I guess that is something that we should appreciate, because, I mean, the problem is there, who is solving the problem? But if somebody sits, think about it, and is able to solve it, then it is good. And then this is possible because somebody also has decided to look at the welfare of the girls. Some people, group of people have sat down and they have thought of how to help these girls to bring out the good in them. And I think that is a very good initiative. And then we pray that everything that is going on, whatever the organization has lost training this girl or supporting these girls, whatever they look for, I mean, God will provide for them so that many more girls will benefit from such a program. And in the shortest possible time, I'm sure the story in Ghana is going to change, because we have brains that think about societal problems and having solutions to the problems.
So we are always available. We hope to see you soon. Take care. Thank you. Bye.